So welcome everybody. Another demo day, Cinco de Mayo. So hopefully you'll be celebrating later on. But before you do that, we have a celebration at Decodable with new features in our developer experience. And I'm going to hand over to Josh, who's going to run us through some of those. And then we'll go into a discussion if anyone has any questions or wants to kind of hang out with the team. So Josh, what have you got for us today?
Great. So I'm Josh Mahonin. I'm a software engineer at Decodable. And the theme of this demo is really developer experience, ways to sort of improve your life as you're using the Decodable product. And there's a number of sort of UI features that we've made enhancements on. But rather than step through this sort of one by one, what I'd rather do is actually run through a real life scenario where we've got sort of expanding on the demo last week. We've got the Confluent Cloud connectors, we've got data streaming to and from, and I want to run through and sort of address some of the questions that were raised on the last demo, which was how do we deal with schema registry, how do we deal with schema migrations, and how do we deal with a failed schema migration? How do we recover from that? So my intent here is to show off not just the new sort of UI features, but also some real life sort of use cases. So I can go ahead and share my screen. So for those of you who are not familiar with Decodable, we're an online streaming ETL product. We use SQL as our sort of execution language. The three main concepts that you sort of need to be aware of are our notion of connections. This is how we get data into and out of the product. We have a number of different types of connectors. So this lets you integrate and bring in either as a source or send data as a sink to things like Confluent Cloud, Kafka, Kinesis, Pulsar, and so on. So that's our sort of connection to the outside world and how we bring data in and how we get them out. Data and streaming records flow into what we call streams. So I'll actually hop in here and show off one of the new UI features. So this is a source connection to Confluent Cloud, and it's configured to a stream. So what that means is data that's coming in from Confluent Cloud is going to be sent to this outbound stream, which is defined here. The thing about streams is really that they're just names and they have schema. So when your data is brought in, a schema is applied to it, and then we can reference it in SQL from a pipeline against this stream name. So you can think of them as sort of like landing spots for the data, either as it's coming in or out, or as you're doing executions within a pipeline. So we'll go back. And what I actually just demonstrated here was the related resources. So I hopped from a connection. This is the source connection, that's Confluent Cloud. It's going to a stream, which we showed the schema of, and it's outbound to a pipeline. So we can really quickly flip between the relationships between these pipeline streams and resources. And so a pipeline, as I mentioned before, this is defined in SQL. And what this does, the sort of important things to know about this is we're always sort of reading from a stream and writing to a stream. And then there's some sort of an operation we're applying. So these are typical sort of SQL functions. This one's pretty simple. We're just doing a select, but you can imagine, windowed aggregations, enrichments, joins, things like that. So that's the sort of high level view of how pipeline streams and connections work within Decodable. So what we're going to do is run through a bit of a real life use case here. So I mentioned that we had this source connection from Confluent Cloud. This is defined as using the schema registry. So if we hop into the details here, this is configured against the cluster API endpoint. We can see there's an Avro schema defined. And we can even see the actual Avro sort of definition here, which is in sync with what's in the schema registry. And there's more configuration options for that below, but this is how this connection interfaces with the schema registry. So I've also got defined here a sync connection. So what we're going to do is we're just going to sort of run through the scenario. We've got a source connection defined. It's Avro schema, and we're just going to send some data to it and sort of make sure that flow works. And the way that we're going to do that, we're going to simulate this, is there's a sync connection defined. And this sync is pointing to that same Confluent Cloud topic, the same endpoint, and we're just going to send data to that. And there's an easy way we can do that now. So one of the new features we have, we'll just hop through from the stream and we'll hop back to this REST source, is via the REST connector. So the REST connector is really interesting. It's a really convenient way of getting data into Decodable. And if you've watched previous demos, the way that you've seen this done is usually with a like a data gen sort of script or using a curl script. You would post, your JSON payload against this this endpoint. It would have some authentication sort of headers associated with it, and that's how you would send it. One of the new features that we've introduced is the ability to upload events to it. So this is really great. There's a new sort of view here, which is pre-populated with the schema attached to the connection. And this schema is, again, pretty simple, value and value2, and they're both strings. But if we go back, we'll look at the overview here. This is connected to this outbound stream, which has the same schema, and that's connected to the sink. So we can really simply begin to sort of simulate, send data to an external topic, an external sort of data store, just with the REST connector, all from the browser. So we're going to go ahead and try this out in a different tab here. I'm going to run a preview so we can see what's happening. If it loads. There we go. So we're just going to run a preview on this data to see what's happening here. I do have a pipeline already set up. It's not running. And we'll just kick off a preview here. So the preview, again, this is reading from our source stream. So I'm going to simulate writing to a sink. This is reading from the source. So it's sort of circuitously going from Decodable to Confluent Cloud and then back again. So we're just going to verify that the data flow is working here. So we'll run a preview and we'll let that start up a little bit. I'm also in the meantime going to just verify this. This is the Confluent dashboard. And I'm going to go back and we're going to go right into this cluster. We're going to take a look at the topic we're going to write to. And we're just going to watch the messages come in. Great. So now we're back to the REST source. And remember, again, this is changed to that sync connector. So we're going to start to send some data to it. All right, so that posted. We're going to check and see here. This is waiting for results. We've got data coming here. Okay, so we can see it worked. We've got data coming into the topic. Previous session canceled. We'll just start that up again. Oh, never mind. This tab worked. Okay, so we can see that our values that we submitted, the foo and the bar, value and value2, they went up. They were sent to Confluent Cloud, and then they came back to the stream all the way through. So that's great. That's sort of the happy path that we'd expect for sending data from the REST connector up to the sink and then back again. So what I'd like to do is start with a schema migration. So, this is a pretty trivial example. There's not much going on here, but you could imagine that this simulated data, there's some business requirement now to add another field to it. There's that extra info that needs to be passed along, or maybe there's different consumers that need this data. And you've got your existing pipeline here that's already set up to read the schema that's already there, and you don't want to break that. So we're going to run through sort of what that scenario looks like. So what I'm going to do is I'm going to go back here, and we're just going to update the schema on the sync side first. We'll stop this. We'll go, actually, we'll update the stream first. We'll go to the schema, and we'll add a field here. And what we're going to do is we're just going to add a new field here. And this is what's known as a backwards compatible change. And I'll get to that in the schema registry in a second. But these are changes that are allowed in backwards compatible mode. You can always add a field to it, especially if there's a default value. And I'll show you sort of what that looks like in the Avro format. So we've added a field to the stream. We're going to go to the sync definition and do the exact same thing. So we're adding this new value3. It's a string, and we'll save it. And we'll go ahead and start the sync. So we haven't actually made this change on the schema registry yet. We're going to go ahead and do that. Typically, you would do this on the schema registry side first and then start the connection. But for demo purposes, we're going to flip that. We'll take a look at the schema here. We can see that it's version 5 and the compatibility mode is backwards. So that's already set up. I'm just going to hide my video so I can see things. Okay. So what we're going to do is we're going to evolve the schema. And this is the Avro schema. It's just a JSON sort of representation of what fields are allowed. And we know that we added this new value field here. So we're going to go ahead and do that. And that's value3. So this is neat. I mentioned that this is in compatibility mode backwards, and we can run this validate sort of step on it, and it's going to say, hey, yep, this is okay. You can run this evolution because it's backwards compatible. So we're going to save that. And we now have a backwards compatible schema defined in the schema registry. That's going to line up with the schema that we've defined on the sync. We can even, if we want to, I'll dive into this later, but you can sort of compare and contrast what you have defined in the schema registry with what's actually shown on the connection here. But one thing we missed was updating the REST connection. So we're going to go and do that. So this schema we need to update here too. So all the way across, we're going to have consistent schemas from our source connector. Oh, it's running, so we'll just stop that. Okay, so we've got consistent schemas from our source connector through to the stream, through to the sync. Great. So we're going to go back. We're going to make sure that this connection is started. It takes a little while, but it should be pretty close. I'm going to pause here and have a little sip of water, and I'll start the REST connection. There we go. Our sync is started. So we'll go back to our REST source. And just as a reminder, our source is still running. So we haven't changed the source. This is still using the old schema. We've added a new version of the schema for the sync, and we're going to try and send some data to it. And we can see here it's got the new field in the REST upload sort of UI here, and we'll just send a payload to it. Oh, and before we do that, I'll actually kick off another preview. And we'll just let that get started first. Okay, waiting for results. Okay, so let's try that. We're going to verify on the Confluence side that we have, oh, I didn't start that first. That's okay. So we sent messages. We're going to check and see. We're waiting for results. I'll just send another one here. We should see that pop up now. Great. So this is a different payload. It's foo-bar-baz. Notice that we have these funny symbols here. That's because it's an Avro payload. There's some binary data that's describing sort of like length of strings and things like that. It doesn't render properly in this UI, but it's a good sort of indicator that we're using Avro under the hood. Back to here. Okay, great. So we ran a preview. This is on the new payload, but we're getting our old fields back. So this is actually, this is a good scenario. We're sending essentially a different payload to the topic, and we're getting a different one back, but it's the same topic and same data. So the way that this works is this associated stream and that associated connection is referencing the schema registry. It's pointing to the previous version of that schema, which is compatible with the new schema. So this is good. We've allowed effectively an existing, running pipeline, running connection to essentially continue to process data, even though the schema has changed sort of under the hood. So that's great. Now, what if there's a requirement here to actually use that new field? Well, we'll just repeat the process that we did before. So we'll go back to our connection here, and we're going to stop our source. And stopping the source, this is, it does checkpointing and save states under the hood, so it's going to pick up where I left off. We're going to go to our schema here. Actually, we'll go to our stream. We'll follow a related resource here, and we will add a new field. So we've updated that. We'll go ahead and update the source. Okay, and we'll get that started. Great. The other thing we'll have to do is we've got a stream, source, and no, we don't need to update the pipeline. That's okay. All right. So the next thing we're going to do is we're going to take a look at the pipeline. And this is another feature that is sort of new to Decodable. We'll take a look at the SQL here. We have this really great sort of entry box for typing in whatever great SQL you want to do your processing. But you might not necessarily know what streams are available. You might not necessarily know what schemas are available. That's where the stream catalog comes into play. So the stream catalog sort of gives you a reference of all of your streams that you have defined under your account. It'll tell you the names of them. You can copy them easily. You can also dive in and take a look at what the schema is. So we've got this new source stream. And as we know, we've added this new field. So these are, this is pretty simple. But in terms of ease of use, you can now sort of copy these values. So value 3, if you wanted, just pop right there. You can copy your stream names. You can also filter down, which is great. So if I look at maybe a more complicated one, like airline events, there's a whole bunch of fields here. Maybe I'll just sort of filter by flight. Okay, and now we can see that just the flight number. So that's really handy. And we can do the same thing for the stream. If we search for, all the Envoy streams, we get that here. So super useful. So we're going to take a look and see how our source connection is doing here. Great. So our source is still clicking. So we'll go back, just give that a second to start. And we'll just double check too that we've done the right thing. So the schema here, 1, 2, 3, we'll go to the overview. Oh, there it's running again. So let's continue double checking. The stream schema is the same and our pipeline is there. So we'll hop into the pipeline and we'll kick off a preview. We're just going to double check here on our Confluence side that we're watching for messages, and we'll send something new. Bar as bot. So we'll post that event. We can see it's showing up here. And here we are in our preview from our source. We can now see we've got that new field showing us. So effectively, this is like the happy path of schema migration. We were able to stop the connection, restart it, and pick up where I left off. And then we're now adding we're referencing this new field that's in the data just by sort of updating the schema defined on the stream and the connection. So that's the happy path. That's great. Sadly, sometimes things aren't quite so happy. We are using a schema registry, and that's got the backwards compatibility mode set. But it may come to pass that someone has a deadline to hit. Maybe they just need to get new data in. Maybe they might turn off that backwards compatibility mode. Maybe they'll add some stuff that's going to break your pipelines. Maybe they don't know it exists. So what happens then? Well, we're going to simulate that. So we'll go to our connections, and we're going to go into the sync. We'll stop it. We're going to update the stream schema. And we're going to do something that is basically disallowed because in backwards compatibility mode, but that's okay. We're going to override that. So we're going to tell this that it's an int. And Aver's got a pretty well-defined set of types. So it knows how to parse a string, it knows how to parse an int. But if you tell it it's a string and it's actually an int, it's going to have some trouble. So we're going to do that anyway and simulate to see what happens. So our sync is now going to send an int there. We're going to update this side too. We'll save that and start it. Great. And so what we need to do here is actually also update the schema registry side like we did before. Technically, we don't necessarily have to using the default settings. It will try and register a new one, but it would fail. So we want to get ahead of it. So again, the compatibility mode here is backwards, and that's why it would fail. This is not a compatible schema. And actually, I'll show you sort of what that looks like. So we're still in backwards compatibility mode. If I try and change this value to an int here, it's going to say, nope, you can't do that. Invalid schema, check the messages. It's incompatible with an earlier schema for a subject. So this is good. This is useful. The schema registry is telling you that what you're trying to do is going to break downstream consumers. But again, someone nefarious might go and change it on you. So oops, I've lost my view. So we'll go to the schema registry. And I'll go this guy. And we're going to change that compatibility mode. So there's a lot of different compatibility settings. I'll get to them in a minute. Right now, I'm going to switch this to none. So that's going to let us kind of do whatever we want with it. And we'll evolve it. And we're going to say, yeah, you know what? I really do want this thing to be an int. And the nefarious sort of data engineer who's we set this is going to break all the downstream connections and pipelines, but not really, not in Decodable. Okay, so that schema has been involved. This is now, and we can see here it's defined as that JSON schema, so values and int. We still have strings and strings here. We will run back and take a look and see how our sync's doing. Our sync's still starting. The overview here has our stream. We'll check that stream schema. That's an int. And we're going to change our rest schema here to also be an int. So now just our whole sort of production simulator here is going to be updated to use ints. And as a reminder, our source, our Confluent source, this is still using strings, right? So it's running, it's expecting strings to happen, to come in. So we're going to see what happens here. So our sync is running. So we're going to hop through this related resource again from the stream to the connection, and we're going to give it some bad data where it's actually the schema registry thinks it's fine, and this connection thinks it's fine. It's just the downstream that's going to have some trouble with it. So I'll say it's bad. We'll need to start this, and we'll upload that. We'll check and see that we got, oh, I wasn't in the right view. That's okay. Pretty sure that's going to work. We're going to take a look and see on our connection side, on our source, what's going to happen with this bad data. There's a reload loop of a few seconds here. We should see an error message as it tries to parse this data coming in, because it is a string. There we go. So we have a nicely sort of well-formed error here, serialization issue with Avro data. There's an underlying problem with the payload of the schema registry. Okay, so that's kind of pointing me in the right direction. It's not giving me a ton of information to go with. So, fortunately, I'm in the position that I caused the error. I know how to fix it. So I'm going to go ahead and do that. But then we'll sort of dive in and see how we might want to properly sort of debug this. If maybe you weren't responsible for that schema change, how would you figure out how to fix it? So we're going to go and fix this on the stream side. And we'll change this to an int. And we'll go back and change this on the, oh, and we have a different error now. That's okay. We know it's the schema issue. And we'll change that to an int. And we'll start that up again. Great. So we're starting this connection. We've changed it. We know it's going to match. But if you're in a position where you actually didn't know what schema change is and you need to do some sort of diagnosis on it, well, we can do that. So if you go to the details page, you'll remember we have the Avro format. We also have the inferred schema here. This is the sort of schema that this connection is going to be using. So if you're in sort of debug mode and you need to find out, okay, what's going on here, and sadly I've already updated it, you can take this and you can compare it with what's actually going on in your schema registry, right? So here's our current version, and using a diff tool or just eyeballing, you would be able to see, okay, is this a string, is this an int, and so on and so forth. So if you're not the person that necessarily caused that problem, you can still sort of use the tooling here to see, okay, my schema doesn't quite line up with this schema, so what do? Do we either roll back the schema version or do we update the connection side? And so in this case, we've chosen to update the connection side. One other thing that is sort of interesting here, and it's talking about schema registry compatibility settings. There are a ton of these. We're currently on none. The sort of proactive move here would be to set it back to backwards to make sure that this same mistake doesn't happen again. Depending on your use case, there's all sorts of different settings here. You might want to be fully backwards compatible all the way to the beginning. If you've got multiple versions of producers, you could have forward compatibility, transitive forward, and full compatibility. So your messages will always be parsed by all producers and consumers. There are a set of rules here on sort of how that works. You'd have to sort of search and see what that sort of matrix looks like. Typically backward is the usual one, but every once in a while someone might flip it to off on you, and you can run into problems. Okay. So we're back to backward compatibility. We do have this updated set. Value is one of a null or an int. An interesting aside on Avro is this is a union type. So this can be either null or it can be an integer. Similarly with value 2, it can be null or it can be a string. This maps back to our schema settings, where we've defined it as a string. You could go ahead and say string not null, and the Avro will reflect that. So we don't actually want to make a change here. Well, let's take a look and see how our connection is doing. Great. So our source is started up again. We're just going to double check our schema again. So this is now going to accept ints. And we'll just check our stream as well using that related resource view. Okay, so all the way through on our source side, we're updated to use ints. So we'll hop into our pipeline view. I'll just get back to that. So we're just going to preview what's coming in from the source. And this is always fun. We'll go back to here and we're just going to check the topic as well. This is the one, messages. Okay, so we're going to see what's going on Confluent here. We're going to see, let's try that one. We're going to see what's going on in the preview, and then we're going to give it some data. So this is the REST source. We're going to upload, and we'll give it some previously incompatible data, but now this is going to be the good stuff. There we go. So we have successfully done a data migration from a bad schema. Again, this is sort of the preview mode, but if you recall that the connection itself is the thing that failed, that's going to essentially prevent anything within the pipeline from consuming that bad data and sort of propagating it, because the protection is on the connection side. There are some settings and flags there we can sort of circumvent that and allow things through or run things to different topics. But for now, the default behavior is simply to disallow that bad stuff coming in, especially when there's a schema registry involved. So that's it. So the recap here is we've demonstrated sort of the new sort of UI features. We've got the REST source and the upload view, which is really handy, especially in sort of cases like this where you're doing sort of ad hoc development and testing. We've got the related resources. So from a REST source, you can see immediately what stream what stream it's attached to. What are the destination sort of connections, the destination syncs, and of course, I'd be remiss if we didn't cover the stream catalog. So again, you can see from your SQL editor, you can see what are your streams you have defined, and what are the various methods or the schema attached to that stream. So that's pretty much it. Are there any questions?
I'd say, Josh, that was a real tour de force, bouncing backwards and forwards between kind of Confluent Cloud and Decodable. Yeah, that's kind of digesting everything that you showed there. Can you say anything about how how the experience has kind of come on in the last few weeks or months, and kind of how you found that improvement helped?
Yeah, I mean, the use case itself is, I'd say, sort of organic. I mean, from the Decodable developer point of view, we run into this stuff all the time as we're testing and building. But it certainly came up in the last call. There's a lot of really interesting questions about, okay, how does schema migration work? What happens when we send, compatible schemas to it? What happens when we send incompatible schemas to it? So I really wanted to just sort of demonstrate that this is something that the platform can handle and we can sort of run with it. But on the other side, we've been doing a lot of work recently, of course, with the Confluent Cloud, easy sort of integration. And that really sort of enables a lot of this schema registry power for us. So it sort of also developed out of that.
Yeah, and it really does seem to me anyway to speak to what life is like actually working with these things in practice, rather than the ivory tower demo greenfield. Things need version control. They do evolve. They're incompatible. Mm-hmm. So it's great to kind of see that kind of get surfaced and how folks would handle that in real life.
Yeah, I don't want to put like a favorite feature because I think they're all really great. But in terms of, sort of the hopping around, and I'm guilty of maybe hopping a lot, but the ability to sort of use the related resources to find what streams refer to which connections, which pipelines, and go back and forth again, that's super useful. It really enables you to quickly sort of iterate and make changes or build new product on it.
So before we wrap up, and if anyone else wants to jump in with comments, thoughts, or questions. If not, we'll say thank you, Josh. There was a lot in there. So this will be back on YouTube, and I should certainly be running it maybe at like 75% speed so I can catch everything.
Perfect. Maybe re-upload it at 75% speed so that it's normal now.
That sounds good. And if no one else has anything last call, we'll end there for today. We'll see you again next week. We'll be looking at async API and data products and building a data mesh. So we look forward to that. Thanks, everybody.
Thank you.